I want to do another example here with asymptotes. This is another rational function, a little bit more complicated. It's f of x equals x plus 2 over x squared minus x plus 6. Okay. So, again, the first thing we have to look at, if we're trying to find any vertical asymptotes, we have to ask ourselves, when is the denominator equal to 0? Okay. So I can take the denominator, set it equal to 0, and solve for x. And I get two numbers in this case. Okay. The denominator is quadratic, so there are two solutions to the denominator being 0. Okay. 3 and negative 2. Okay. Now, it turns out in this problem, one of these is an asymptote, one of them is not. Okay. So which one is an asymptote? Well, 3 is an asymptote. And again, you can find out all the information by looking at the limit as x approaches 3 from the left of this function, and the limit as x approaches 3 from the right of the function. Just like we did in the last example, I think it will curve up on one side and curve down to the other side. One of these is going to be infinity, and the other one's going to be negative infinity. Okay. But negative 2 is not a vertical asymptote. And again, this is why I chose this example to talk about when the denominator is 0, but you don't have a vertical asymptote. Okay, so let's talk about that. Why is negative 2 not an asymptote? Well, here's why. In fact, the limit as x approaches negative 2 from either side is not going to be infinity or negative infinity. If you wanted just to pick one, you could, but I'll be able to show you that the limit as x approaches negative 2 from either side is actually just a particular number. Okay, so let me put the function in here. So if we wanted to figure out if there's an asymptote, remember what the book says for that is that we have to figure out if the limit as x approaches that number where the denominator is 0 is infinity or negative infinity from each side. Okay, but I don't even have to look at each side separately because of what happens here. Okay, this limit, I can't use direct substitution just yet, because if I put negative 2 in for x, it makes the denominator 0. Okay, but it also makes the numerator 0. And if you notice, this one is kind of special, because if I do a little bit of algebra first and I factor the denominator, well, I already factored it over here. It factors as x minus 3 times x plus 2. Okay? So it just so happens that x plus 2 is a factor in the numerator as well. Okay? So when I'm computing the limit, I can actually cancel these factors. So this limit is going to be the same as the limit as x approaches negative 2 of 1 over x minus 3. Okay. So now that I've canceled that factor, which I was able to do with the x plus 2, but not the x minus 3, of course, I can just plug negative 2 in for x. And I'll get 1 over negative 2 minus 3, that's negative 1/5. So bottom line, if you were to construct a table for this one and look at the limit as x approaches negative 2 from the left and from the right, you're not going to see infinity or negative infinity. You're going to see that the limit is negative 1/5. Okay, so this one doesn't have a vertical asymptote when x is negative 2, because from either side, in fact from both sides, the limit of the function is just negative 1/5. So all that means is that when x is negative 2, this function's undefined. It has what the book calls a removable discontinuity. It's just a little hole in the function. There's no asymptote there. So if you graph this one on the calculator, you'll see that there's an asymptote when x is 3, pretty clearly, but it won't look like anything special is happening at negative 2 because there's no asymptote there. Okay, now actually the function technically isn't defined when x is negative 2, but there's no asymptote there. So the graph will look pretty innocent at that point. So that's an example of when the denominator can be 0, yet you don't have a vertical asymptote. Bottom line is you need to look at the limit as x approaches that point from both sides. And if it's just some particular number, then there's no asymptote.